Now next we are going to perform meshing. Right click on it and give edit. Meshing will open. Mesh will open. So before performing simulation, I want you guys to know about what the exact definition of combustion is. So before performing the simulation, we must know the basic fundas where we're doing combustion. So you should know what is combustion means and what are the types of fuels that is used in aerospace and aeronautical applications. You must go through them and you must mention them in your record. What are the fuels that are used in the theory part? Okay, so the mesh is open. This is our geometry which we have done in the geometry session, and we're going to click on Z axis. Now this is our model. So here we're going to perform the meshing. So go to mesh, right click on it, you will find insert, and if you fly over it, you will have some flyouts such as method, sizing, contact sizing, refresh, refinement, phase meshing, all these things. So let us select sizing first. Okay, we're going to do sizing, right? So here we'll select the geometry. Now we have to select the edge. Okay, we have to select the edges. First we'll select these edges such as 1. Click on control. Click and hold on control. 2, 3, and the top one, 4. If you apply, you should see 4 edges have been selected. Okay. Now you see the type. The type is element size, but we'll give it number of divisions. Here we will give number of divisions as 4, and okay. Here you have to double click on capture curve. So behavior, again double click, it should be hard. We're going to be hard on this behavior. Okay. Then here we have done this edge sizing. Then again select, we are going to do like this a couple of times again, and sizing again. Here we are going to select these edges, 1, 2. Now we have selected horizontal small edges. We are going to select now vertical small edges. Go here again. Here we are left with again 2. Click here, 1, 2. So if you apply, you'll get 4 edges. You must be getting 4 edges. And again type element size, double click on it, it will change to number of divisions automatically. Here you give 6. Okay. Then again double click on capture curve. Growth rate will be 1.2 default. Let's not change anything, and let the behavior be hard again. Okay. Now here you can see, if you zoom it, you can see the number of divisions. There will be 6 divisions on each edge. Okay. Now let us perform one more sizing. Here now we are going to click on this edge and click on this edge and apply. We'll be having 2 edges. Now again number of divisions. Number of divisions you give something around 240 divisions. Okay. Again double click on capture curve. Then double click on behavior. Here you will give something called bias. Okay. Bias, you will have this kind of pattern, and bias factor you will give 6. So you can see the spacing between the edges has been increased. That is what bias factor is. Now if you give bias factor 12 or something, the spacing will increase from this edge to this edge, this division to this division. So depending on the bias factor, your mesh will be distributed accordingly. So bias factor is important when you want the mesh to be distributed elsewhere even. That is where bias factor plays an important role. Okay. I have to select the first one. Okay. Now if you select the first one, what is happening? The first one is getting from ascending to descending order, but the second one is getting from descending to ascending. We want the both to be in the same way. So what we do, we go down, we see something called reverse bias. So click on this edge again and give apply. Now this thing will get same. So you have to give reverse bias anything you can give, but it should be from ascending to descending. Okay. Now one edging is finished. Let us do one more edging. That is the vertical big ones. Okay. Now select this edge, then again select this edge, control and apply. Okay. Number of divisions here you give something around 60. Okay. Again capture curve, behavior hard. Here also you'll give bias, right? Here also your mesh should increase gradually. So here bias factor you give somewhere 12, and check whether here it is going from ascending to descending, and check whether it is going from ascending. No, it is not going. See. So what happened? You select this reverse bias, click on this, and click on apply. So it will be from ascending to descending. Okay. Now your mesh sizing is been given, right? So next step you will do is generate. We'll generate the mesh depending upon the system performance. Your mesh will be generated fast or slow. So the meshing is done. As you can see, this is an unstructured meshing, right? So for a simulation to occur in our desired way, so that there won't be any errors, our mesh should be structured. So how to do it? So one simple trick. Again, go to click on right click on mesh, insert. Now you click on face meshing. Now you're asking for the geometry. You click on the geometry and apply. Now again give generate. Keep the options as it is. Now the meshing is done. Click on mesh. You see now the mesh is structured, right? Here the mesh is more concentrated. Why we will say we'll talk about it later. Why it is concentrated here and it is not here. So this is how the meshing should be done. So before going to next part to where we do the setup. So for setup we need boundary conditions, right? So boundary conditions are mandatory. So we give the boundary conditions here itself. What to do? You click on this, select this edge. Here you can this is the flyouts, or this is the region where you can select a point, a edge, a face, and a whole body. Now we're going to select edge. Click on this, right click on this. You can see create name selections, or you can use shortcut N. Okay. This one will give something called inlet air, because from here air is going to enter. Okay. What from here? This region air is going to enter. Now here you give this as inlet methane. Methane is nothing but CH4. So you will give this as inlet of methane. So this one you will give something by name nozzle, and these two just leave it like that. And this one, this edge and this edge you select and give this as symmetry. We'll see why it is given symmetry now. Let us check. Yeah, it has given on. This is where your name selections will show. We give symmetry. See, this is not selected. So what to do? Again, let us delete this again. Yes, no problem. Then now click on this again. Control. Now control. Yeah. Okay. Now create name selection. Now give symmetry. Now this again select this. Control and select them. Then create. Give the name as wall. This will be our wall, and this will be our symmetry surface. We'll talk about why symmetry is given and why giving symmetry condition is necessary or crucial in simulations. So this will be our inlet air. We see this will be our inlet air. This is our inlet CH4. This will be our nozzle, and this will be our symmetry, the down part, the down edge, and the upper edge will be wall. So the edge, there should be an outlet. So click on all these three edges here. View this as outlet. Okay. Now generate, and this is the mesh you have. Okay, it is very structured, and you have given the name selections. This inlet air, inlet CH4, nozzle, symmetry, wall, and outlet. Okay, this is what meshing is about. You can close the meshing, and here you can see a thunder symbol, right? You right click on it. That means you have to update it. If you update it, all named selections, the meshing will be updated. Once the mesh is getting updated, the next step is to proceed with the setup. In this setup, the Fluent setup is where the simulation take place, where we give the boundary conditions and everything.